Hello everyone, today we are starting 11.2b. Again, we are simplifying radical expressions. So the first three problems here are just a review of what we did yesterday. If we have the square root of 10x times the square root of 2x, what we can do is make one big radical, put 10x times 2x underneath it. So now we can solve this by multiplying the 10 and the 2. So we're going to get 20x and x, so x squared. So if I factor the 20, I'm going to take a 4 and a 5 out. The 4 can be simplified even more, so 2 times 2. So I found a pair, so I'm going to write that 2 down there. The 5 can't be simplified, so I'm just going to leave it like that. Then the x, they both have just one x, but because that's a pair, it becomes x squared, which simplifies to x because we have that pair. And then we just have last the square root of 5. Next one, 25, that can be split up into 5 times 5. So that's a pair, so I'm going to write that down here, 5. Then n can be split up 3 different ways. So n, n, and n. I see one of my pairs there. It's going to be n. What I have left is just a single n, so I'm going to have the square root of n. Next one, we have a division problem. So this is the same as the square root of x squared over the square root of 144. So the square root of x squared is just x. Square root of 144 is 12. Our answer is x over 12. Now, we cannot have a radical in a denominator if we have a fraction. So what we're going to learn today is how to eliminate a radical from the denominator of a radical expression. Now really all that we do is we're going to multiply this entire expression by the square root of 3 over the square root of 3. We're going to multiply it by the denominator. So if we do that, this is actually a 1 times the square root of 3. 1 times 1 is going to give us 1 times the square root of 3. Square root of 3 times the square root of 3 is going to give us the square root of 9. Now that can be simplified to 3 times 3. So that's our pair. Our answer is going to be 1 times the square root of 3 over 3. If we wanted to write it as just the square root of 3 over 3, we could, because we don't need that 1 out there if we don't want it. Here I'm going to multiply the whole thing by the square root of 7. Now I have a 1 on the outside of this, so it would be 5 times the square root of 7 over the square root of 49. Which simplified, the square root of 49 is 7. We can't do anything to the top, so it stays the 5 times the square root of 7. Here we're multiplying by 3b, the square root of 3b. So we're going to multiply the top, the numerator, and the denominator by 3b. This time what we're going to get is, on the top, the square root of 6b over the square root of 3 times 3, which is 9, b times b, which is b squared. So the square root of 6b can really stay like that. We can't really do much to it, because if we split that up, it would be a 2 and a 3, which don't have any pairs anyway. But we can split up 9. That has a 3 times 3. So it has a pair of 3's. It also has a pair of b's, so 2 b's. So what we're going to have then is the square root of 6b over, we found a pair of 3's and a pair of b's. So the square root of 6b over 3b. Here we're going to multiply by the square root of 2x. Now we imagine that they have a 1 in front of both of these. So 3 times 1 is going to give us 3 times the square root of 2x. The square root of 2x times the square root of 2x is going to give us the square root of 4x squared. We can split up 4 times 2 times 2. That's a pair. I'm going to circle that. And x squared, that's x times x. Another pair, I'm going to circle that. Can't do anything to the top, so this is going to stay 3 times the square root of 2x over 2, that's our first pair. Our second pair is x. Next one, we're still going to multiply the numerator and denominator by the denominator. So we'll have 1 times the square root of x over the square root of x squared. Now the square root of x squared, I can take x and I get a pair. We don't need to write this 1 because we know that that 1 times anything will be the same thing. So I'm just going to write the square root of x over x. Now this next one, we are going to find if we divide 4 divided by 52, what we're going to get is the square root of 1 over 13. So now what I'm going to change that to is the square root of 1 over the square root of 13. The square root of 1 is going to stay 1, but we have the square root of 13 still on the bottom. So we can't have the denominator be a radical, so we're going to multiply by the square root of 13. So it's going to stay the square root of 13 for the denominator, or the numerator. The bottom this time is going to be 13 times 13, the square root of 169. So the top, or the numerator, stays the same, the square root of 13. The square root of 169 is 13. So our answer is this. Now, adding and subtracting radicals. We're going to think about this as if we were combining like terms. So we're going to think of the radical as an x. So I'm going to have 2x plus 6x. If I add those together, I get 8x. We're going to do this the same way. We're going to think of the radicals as x's. So we're basically going to have 2 plus 6, which is 8. Then the radical stays the same because they were both 2's. Next one, how are we going to subtract something when there's nothing in front? Well, we know that there's always going to be a 1. 1 times anything will still give us the same thing. So here we have 1 minus 6. Now 1 minus 6 is going to give me negative 5. Because I have the same ending term, the square root of 5, I'm just going to add that like this. Here we don't have the same radical. We have a 63. Now what I'm going to do is I'm going to factor that out. So I'm going to get 9x and 7. The square root of 9 is 3 times 3. So I see a pair, so I'm going to drop that down here. And then the square root of 7 I can't really do anything with, so I'll leave that like that. Now this 3 comes down as well, so it'll be 3 times 3 plus this whole thing 2 to the power of, or 2 square root 7 comes down as well. Now we both have, we have two of the same radicals. So in this case we have 2 square root 7 plus 3 times 3, which is 9 square root 7. Now we have the same radical, so we can just add the outside terms. 2 plus 9 is 11 square root of 7. Next one, same thing. We are going to factor 48. Now I know that 48 can factor into 6 and 8. 6 can factor out to 2 and 3. 8 can factor out 2 and 4. And 4 can factor out 2 and 2. So I see that I have a pair. I'm going to put that 2 down there. I see that I also have 2 more 2's, so I'm going to put another 2 down there with it. And it looks like we just have the square root of 3 left over, plus 5 square root 3. Now we have the same radical. So we'll have 5 square root 3 plus 4 square root 3. 5 plus 4 gives us 9 to the square, or times the square root of 3. Alright, here I see two of the same radicals, one here and one here. So what I'm going to do is I'm going to think of those as just my like terms. I'm going to add 4 minus 9. So it's going to give me a negative 5 times the square root of 10. Now what we have left is just the square root of 13. So I'm just going to put this down here. 1 times the square root of 13. I can't combine those, so this is my answer. Now here I don't see any of the same radicals, but what I do know is that I can factor out my 12. That's going to give me a 6 and a 2. My 6 can be factored then to 2 and 3. What I see that I have now is a pair of 2's. So I'll have 2 times the square root of 3 plus 6 times the square root of 3, that comes down from here, plus 2 times the square root of 6. Now I see my like terms are the square root of 3's, so 2 plus 6 is going to give me 8 to the square root of 3 plus 2 to the square root 6. Alright, now we have a real world problem. So it says, a doctor may need to know a person's body surface area to prescribe the correct amount of medicine. A person's body surface area in square meters is given by the function A equals the square root of h times w over 3,131, where h is the height and w is the weight. For A, find the body surface area of a person who is 5 feet 5 inches tall and weighs 110 pounds. Round your answer to the nearest tenth of a meter. Well, I can't really multiply something that is feet and inches, because I know that h is the height in inches. So what I can do is convert my feet to inches. I know that 5 times 12 is going to be 60. Then I know I have an extra 5 inches, so 60 plus 5 gives me 65. So my area is going to be the square root of 65 times 110, because that's how much they weigh, over 3,131. Now, this is a lot of work, so what I'm going to do is I'm just going to put it in my calculator, and what I get is about 1.5 meters square. Next one, same thing, but this time it's 5 feet 10 inches tall. So the square root of 60 plus 10 this time, so 70. And then they weigh 120 pounds over 3,131. If I put that into my calculator, I'm going to get about 1.6 meters squared. Alright, now multiplying radical expressions. So we talked about adding and subtracting. Now we're going to talk about multiplying. So when we multiply these, we have basically something that looks like when we factored trinomials. So we're going to do the same thing we did then, and I'm going to draw a box, a 2x2 box, to help me multiply. On the first side, I'm going to have 4 minus the square root of 5. On the top, I'll have 1 minus the square root of 5. Well, I know 4 times 1 is 4. 4 times the negative square root of 5 is going to be negative 4 times the square root of 5. 1 times the square root of 5 is going to just be, well, negative square root of 5 is going to be a negative square root of 5. And then the square root of 5 times the square root of 5 is going to be a positive square root of 25. So I'm going to write this out then. So I get 4 minus 4 times the square root of 5 minus 1 times the square root of 5 plus the square root of 25. So I can add these two together because they have the same radical. Negative 4 minus 1, that's going to give me a negative 5 times the square root of 5. Square root of 25 is 5, and then the 4 comes down as well. Last thing we can do is add up our like terms again. So 4 plus 5 is going to give me 9 minus 5 times the square root of 5. Here all we're doing is distributing the square root of 5. So for this one, I'm going to have 1 times 5, so it'll be 5 times the square root of 5, minus this time I'm going to multiply 2 square roots of 5, so I get the square root of 25. So I know that the square root of 25 is 5. And I can't do anything with 5 times the square root of 5, so I'm going to leave it like that. And our answer stays just like that. Alright, last two problems. Again, I am going to draw my box for this one. I'll have the square root of 7 times the square root of 2 the square root of 7 minus 3 times the square root of 2. The square root of 7 times the square root of 7 is the square root of 49. This is going to be a negative 3 times the square root of 14. Here it's going to be just the square root of 14. And then finally, it'll be a negative 3 times the square root of 4. So if I write this all out, then I'll have the square root of 49 minus 3 times the square root of 14 plus the square root of 14 minus 3 times the square root of 4. Now remember to add this 1 in front, because now we have negative 3 plus 1. We can add these together because they have the same radical. When we do that, we get a negative 2 times the square root of 14. The square root of 49 is 7. And we can do negative 3 times the square root of 4, which is 2. So we'll get 7 minus 2 times the square root of 14 minus 6. Add these two together, and we'll get 1 minus 2 to the square root of 14. Last problem, this is squared, so what this is saying is we basically have this twice. So if I draw this box, then we'll have 2 times the square root of 5 plus 7. 2 times the square root of 5 plus 7. 2 times 2 is 4. Square root of 5 times the square root of 5 is the square root of 25. 2 times 7, that's 14. And the square root of 5. 2 times 7 is 14. The square root of 5. 7 times 7 is 49. So we'll have 4 times the square root of 25 plus 14 times the square root of 5 plus 14 times the square root of 5 plus 49. These two have the same ending. I'm going to add them up. 14 plus 14 is 28 times the square root of 5 plus 49. And then the square root of 5 is 5, so 4 times 5. So 20 plus 28 times the square root of 5 plus 49. Then I have two like terms, 20 and 49. I add that up to 69 plus 28 times the square root